We're going to continue on with the anatomy of the respiratory system and look at the forces for pulmonary ventilation. It's really important to remember with the thoracic cavity that it's airtight. The only place that there will be air inside the chest cavity is inside the lungs. And air can only enter and exit the lungs through the trachea. And then the chest wall is there to protect the lungs. Here's a picture of the thoracic cavity. I just want to point out the diaphragm, which is the parachute-shaped muscle that makes up the bottom of the thoracic cavity, and then also the intercostal muscles, which are in between the ribs. So both these muscles and the diaphragm are going to be used for breathing at rest. And then the next thing we need to look at is the pleural sac. So the pleura is just the membrane that lines the lungs and the chest wall. And the pleural membranes will make up a pleural sac around each lung. So each lung will have its own pleural sac and they are not connected to each other. The pleural sac has two layers. There's the visceral pleura and the parietal pleura. The visceral pleura is going to be attached to the outside of the lung wall. And then the parietal pleura will be attached to the inside of the chest wall. And then in between the visceral and parietal pleural layers, there's an interpleural space. And that's filled with a little bit of fluid called interpleural fluid. And the pleural sac is really important because having those two layers of the pleural sac, the visceral and parietal pleura, I like to think of them as being microscope slides. And then in between them, you've got the interpleural fluid. And so you can slide the microscope slides against each other really easily. And that fluid will also decrease the friction as the lungs are inflating and deflating. But the other thing is that if you try to pull the microscope slides apart, it is really hard to do and it creates a suction cup. And this negative pressure is going to stick the lungs to the chest wall. Here's a picture of the pleural sacs. There is a pleural sac around each lung. And notice that there are two layers that make up the pleural sac. So the inner layer is the visceral pleura, and that's attached to the outside surface of the lungs. And then the parietal pleura, parietal means wall, and that's going to be stuck to the inside of the chest wall. And then in between those two pleural layers, you have the interpleural space or the pleural cavity. And there's a little bit of interpleural fluid in there that will decrease some of the friction and also help create the suction cup that's going to stick the lungs to the chest wall and prevent the lungs from collapsing. Here's a close-up of the pleural sac. You can see the visceral pleural layer, and that's attached to the outside surface of the lung. And then you can see the parietal pleural layer that is attached to the inside surface of the chest wall. And then in between you have the interpleural space filled with a little bit of interpleural fluid. Let's look at the forces for pulmonary ventilation or breathing. Pressure gradients drive airflow, and we saw that before with pressure gradients driving blood flow. So air is going to flow down its pressure gradient from high pressure to low pressure. So the pressure gradient is going to be formed between the air inside the lungs and then the air that's outside the body, which is called the atmospheric pressure. And there's two phases of pulmonary ventilation or breathing. Inhalation, the pressure inside the lungs is less than the air pressure that's outside the body, so air will move down the pressure gradient and into the lungs. And then during exhalation, the pressure in the lungs is higher than the atmospheric pressure outside the body, so air will then flow from the lungs to the outside. It's really important that you know all four of these pulmonary pressures and also their abbreviations, so make sure you star this in your notes. The atmospheric pressure is just the pressure of the air outside the body, and at sea level the atmospheric pressure is 760 millimeters of mercury. Here in Salt Lake, the atmospheric pressure is 660, but we're just going to assume that we're at sea level, and we're going to be comparing all of these other lung pressures to the atmospheric pressure, so it's just easier if we set the atmospheric pressure at 0, even though we know it is 760. The interalveolar pressure is the pressure of the air inside the alveoli. The interpleural pressure is the pressure inside that interpleural space. And the transpulmonary pressure is the pressure across the lung wall. So we calculate that by taking the intraalveolar pressure and subtracting the interpleural pressure from that. And the transpulmonary pressure is really important because that's the force for expanding the lungs. This is really important to know. I'd started this in your notes. The pressure gradient that drives airflow into and out of the lungs is the pressure difference between the atmospheric pressure, so the pressure of the air outside the body, and the intraalveolar pressure, or the pressure inside the lungs. During inhalation, the intraalveolar pressure will be less than the atmospheric pressure. So atmospheric pressure is set at 0, and the intraalveolar pressure during inhalation will be at -1. So air is going to flow down the pressure gradient, going from high pressure outside the body to lower pressure inside the lungs, so air will flow into the lungs. And then at the end of inspiration and right before you exhale again, there's a little bit of a pause where there's no air flowing in or out of the lungs. And that's because at the end of inspiration before you exhale again, the intraalveolar pressure is the same as the atmospheric pressure. So they're both going to be 0. So there's going to be no airflow in between inspiration and expiration. And then when you start to exhale, the intraalveolar pressure, the pressure inside the lungs, is higher than the atmospheric pressure, the pressure of the air outside the body. So air is going to flow down the pressure gradient, going from high pressure inside the lungs to lower pressure out in the atmosphere outside the body. So air will flow out of the lungs during exhalation. The interpleural pressure is really important. It's always going to be negative, and it's going to create a suction cup that sticks the lungs to the chest wall. And the interpleural pressure is always going to be less than the intraalveolar pressure, the pressure inside the lungs. And then the interpleural pressure will vary. So at the end of exhalation, it will be at -4 millimeters of mercury, and then as the chest wall expands, at the end of inhalation, it will be -6 millimeters of mercury. What creates the negative pressure inside that interpleural space is that you've got the 2 layers of the pleural sac. The parietal pleura is attached to the inside of the chest wall, and the chest wall always wants to expand outwards. And then the visceral pleura attached to the outside of the lungs always want to recoil inward and collapse. So you've got the 2 microscope slides here, and you've got a little bit of interpleural fluid in between them. And if you're always pulling on the 2 microscope slides or the 2 layers of the pleura, you're always going to be creating a suction cup or negative pressure there. So this will keep the lungs from collapsing. It actually sticks the lungs to the chest wall. The transpulmonary pressure is the pressure across the lung wall. So we calculate this by taking the intraalveolar pressure, the pressure inside the lungs, and then subtracting the intrapleural pressure, so that pressure in the interpleural space. And this is the force for expanding the lungs and keeps the lungs from collapsing. So let's take a look at how the transpulmonary pressure works. Here's what happens to the transpulmonary pressure between exhalation and inhalation. So let's start over here at inhalation on the right. And at the end of inhalation, there's a little bit of a pause before you exhale, and there's no air moving in and out of the lungs. And that's because the intraalveolar pressure, the pressure inside the lungs, is 0. It's the same as the atmospheric pressure. The interpleural pressure at the end of inhalation will be at -6. And that's because at the end of inhalation, your chest is expanded, You're pulling more on those microscope slides, the 2 layers of the pleural sac, and so you get a greater negative pressure at the end of inhalation. So the transpulmonary pressure at the end of inhalation will be 6, and so that's the greatest force that the transpulmonary pressure will be at the end of inhalation. That's the force for expanding the lungs. At the end of exhalation, there's a little bit of a pause again before you inhale, and the air is not moving in and out of the lungs because the interalveolar pressure is the same as the atmospheric pressure. The interpleural pressure at the end of exhalation is at -4, and that's because the chest wall has fallen back in a bit and you're not pulling on the microscope slides as much, so you're not creating as much negative pressure. So at the end of exhalation, the transpulmonary pressure goes down to 4. So there's not as much pressure expanding the lungs. But notice that at the end of exhalation, the transpulmonary pressure does not go to 0. And that's good because you still want to have some pressure across that lung wall, keeping the lungs expanded and not letting them collapse. And this is just showing you at the end of exhalation what the transpulmonary pressure is doing. So here's our intraalveolar pressure. The pressure inside the lungs is 0. And here's our interpleural pressure at -4. So the transpulmonary pressure, the pressure across that lung wall, the force for expanding the lungs is at +4. A pneumothorax is a bad thing to have. Pneumo means air and thorax is talking about the chest cavity. So air is going to be entering into the intrapleural space, either through the chest wall being pierced, maybe by a knife wound, or there's a hole in the lungs where maybe the person had a rib fracture and the rib maybe lacerated the lung. So air is going to enter into this intrapleural space. Normally the interpleural pressure is negative. You have that suction cup there. But with air entering into the intrapleural space, now the interpleural pressure will be 0, the same as the atmospheric pressure. So you lose that suction cup. The lungs are no longer going to be suction cupped to the inside of the chest wall. And you've lost that transpulmonary pressure, the pressure for expanding the lungs, and so the lungs will just recoil and collapse. And that's going to make it hard to breathe because once the lung is collapsed, it's really hard to reinflate it. So the person's going to be very labored with their breathing. And the way we treat this is you place a chest tube, which is then hooked up to a suction machine to remove the air from that intrapleural space. This shows what happens to the transpulmonary pressure during a pneumothorax. So the intraalveolar pressure inside the lungs is 0, and then the interpleural pressure goes to 0 as well. It's going to be the same as the atmospheric pressure because now there's air in that interpleural space. So you've lost that suction cup. The interpleural pressure is no longer negative. And note that the transpulmonary pressure is 0. So there's no force for expanding the lungs, and the lungs will recoil and collapse and make it very hard to breathe. This is a nice summary of the pulmonary pressures, so make sure you star this. These are really important to know. The pressure gradient that drives air into and out of the lungs is the difference between the atmospheric pressure, the pressure of the air outside the lungs, and the intraalveolar pressure, so the pressure inside the lungs. So that pressure gradient is going to drive airflow into and out of the lungs. And then the transpulmonary pressure, that's the force across the lung wall, and that's the force for expanding the lungs. And remember, that's the difference between the intraalveolar pressure and the interpleural pressure.